Hey guys, so this is the first in 3 videos about Kc. This is the first one, this is Kc for beginners. And what we're going to talk about today is how to write a Kc expression, how to use that expression to calculate a value for Kc, and then how to figure out what the units for that value will be. So the first thing we're going to do is construct a Kc expression. I've put an example equation up here. We've got 2SO2 plus O2 reversibly goes to 2SO3. When you're constructing a Kc expression, and what Kc is called is the equilibrium constant. What it tells you is whether your position at equilibrium you have a higher concentration of reactants or a higher concentration of products. Basically, the greater Kc is than 1, the higher the concentration of products you have compared to reactants at equilibrium. This only works at equilibrium. If your system is not at equilibrium, you cannot find the Kc because this is the equilibrium constant. So it's got to be equilibrium, that's the most important point. And the examiners will try and trick you out loads by asking you questions about something which isn't at equilibrium, and you'll do Kc, but you can't. So, to construct our Kc expression, all we do is we take the concentration of our products raised to the power of their molar ratio. So, this product here will be raised to the power of 2. And we divide that by the concentration of the reactants, again, raised to the power of their molar ratio. So, to use this example, I've got my concentration of the products on the top. So that's going to be my SO3, raised to the power of 2, because that's its molar ratio, its stoichiometric ratio, and divide that by the concentration of my reactants, which will be SO2 to the power of 2 times by O2. These square brackets are just a quick way of saying the concentration of. So this is the concentration of SO2. Okay, we'll go for another example. If I had the equation CH4 plus 2O2 reversibly goes to CO2 plus 2H2O. Again, my Kc expression would be products on the top, so it's going to be CO2 times the concentration of H2O to the power of 2. All divided by my reactants, so CH4, O2 to the power of 2, because that's this big number there. So it's fairly easy. That's how we construct our Kc expression. What's quite a lot harder to do is to pop in our concentrations and actually figure it out. So I'm just going to write up a few concentrations on the board and then show you how I'd add them in. So at equilibrium, we're assuming all of this is at equilibrium, the concentration of CH4 is going to equal 3, the concentration of O2 is going to equal 5, CO2 will pop as 1, and H2O will have a 6. So let's pop them in there. So again, Kc is going to equal, there's my products on the top, so CH4 is 3, product CO2 is 1, times by H2O, which is 6, but don't forget, raised to the power of the number, which will be 2. Divide all that by my CH4, which is 3, times by my O2, which is 5, again, that's going to be to the power of 2. So using my cheat sheet, because my maths is absolutely rubbish, that will give you 36 over 75, which again, popping that in a calculator, will give you 0.48. So your Kc value for these concentrations at equilibrium would be 0.48. That's significantly less than 1, so what that tells you is at equilibrium you have a higher concentration of reactants than you do products. Okay? And if we were to increase this, what it would mean is you have more products in terms of concentration than you do reactants. So that's how we'd pop in our concentrations into the Kc expression. Sometimes you might have to figure out the concentration by using one of your 3 moles equations. So volume of a gas divided by 24, mass over mR, or volume times concentration. And don't forget, if ever you do that, the volume has to be in decimeters cubed. Otherwise, your answer will be out by a factor of 1,000, and that's pretty wrong. So, finally, we're going to calculate the units for Kc. Now, units are not that bad actually. Units are pretty easy to figure out. All you need to do is reconstruct your Kc expression. So my Kc expression, just to quickly do this. So I've reconstructed it. And then what we do is, each of these is the concentration of something. So that means the concentration of CO2. So what I'm going to do is I'm going to replace this with the units of concentration, which is moles per decimeters cubed. So I've got a moles per decimeter cubed there. I've got 2 moles per decimeter cubed there, because there's 2 of them. And on the bottom, again, I've got a moles per decimeter cubed. And 2 more moles per decimeter cubed. So I write out all my concentrations as their units. I then cancel a moles per decimeter cubed on the top with a moles per decimeter cubed on the bottom. Boom, done. Whatever's left over will be your units for Kc. Now, it's a bit weird this one, because in this case, there's actually nothing left over, and that's perfectly fine. Kc can have no units, but in the exam, you have to actually write that. Don't just leave it blank, don't put 0, you have to say Kc has no units. So my answer would be, has no units. That's perfectly fine. I'll give you a mark. Okay, I'll pop another one up on the board now, and what I'd like you to do is stop the tape, the video, have a go at doing it yourself, and then start the video when you've done it and check if you've got it right. Okay, so we'll go back to our old expression. So stop the tape, have a go at writing the units for Kc. You'll probably need to write a Kc expression first to do that, and then we'll go through in a second. Okay, so let's go through it. So Kc equals my SO3 squared over my SO2 squared my O2. So popping in my units, I've got 2 moles per decimeter cubed on the top, and I've got 3 on the bottom. Now, if you're good at this, what you can just do is say, right, there's 2 on the top there, there's 2 on the bottom there, so I can cancel those out just to leave that one. And that would save you a bit of time in the exam, because you don't have to write all this out. But just whilst we're practicing and getting used to that, let's write it out for now. I then cancel them. Well, I've got 2 on the top, which will cancel with 2 on the bottom, and that will give me 1 over moles per decimeter cubed. We can't leave it like that though. We have to have it with our moles and our decimeters on the top. Now, if you do maths, you'll probably know what I'm doing now. If not, this might be a bit new to you, but you just have to kind of go with it. I'm just going to rub this out to get a bit more space. If I want to put my moles and decimeters on the top, so flip them up here, all I need to do is reverse the sign of the power. So this at the moment is moles to the 1, but we just don't bother writing it, but it is. Moles to the 1, decimeters to the -3. If I flip this to the top, it's moles to the -1 decimeters cubed. Okay?